Let us study a new chapter, space missions. Now, what is meant by space missions? Space missions means space exploration. Now, what is meant by space exploration? Space exploration means traveling through the space to learn about space. Now, for traveling through the space from different countries, send satellites and orbit them in the different orbits of the Earth, Moon, even some other celestial body like Mars. As a result of it, we get various information about different countries. Now we can say that here in India, we are having ISRO, that is the space center which is in India. It has number of branches in various parts of India. Now, in India, there are two rocket launching centers are there. One is in Sriharikota, that is in Andhra Pradesh. Second one in Kerala, that is at Thiruvananthapuram. In Thiruvananthapuram, we are calling it as Tumba Equatorial Rocket Launch Station. In Sriharikota, its name is Satish Dhawan Space Center. These two places or these two mission centers, we can say, from there rockets or satellites, artificial satellites launching. Then these rockets or we can say satellites, artificial satellites, orbit on different orbits of the Earth. Now, for what purpose we are sending artificial satellites to the different orbits of the Earth, Moon, Mars, etc. Its purpose is there or its objective is there. Objective is there. First objective or first purpose, that is, we can say that research work as well as for various applications. Second thing, we can say that for studying as well as for understanding, for observing different objects which are there in the solar system. So we can say that we are sending satellites into the different orbits of the Earth. Now we can say that two categories of satellites are there. The first thing, as I told you, for the research work as well as for various other applications. Second category or second type of satellites which we are sending, that is for studying about the studying as well as we can say observing different objects which are in the solar system. Here in the world there are different space centers. Out of all space centers, number one rank we can say that is to NASA, which is in United States. This NASA, its full name is National Aeronautics and Space Administration. This NASA is in USA. That is ranking first, we can say, in space mission. Second position, that is to CNSA, that means China National Space Administration. This space center is in China. China ranks second position. Now, ESA, that is European Space Agency, it is in the third position. Here ESA is in Europe. The fourth position, that is RFSA, Russian Federal Space Agency. Russian Federal Space Agency. This RFSA is in Russia. Then fifth position, RFSA, that is Russian Federal Space Agency, is having fourth position in space mission. Then the fifth position to ISRO, ISRO, which is in India. Its full name is Indian Space Research Organization. Now, these all space missions are running by the government of own country. So here we can say ISRO running by India, Indian government. Now here rocket launching centers of India we studied. One is in Thiruvananthapuram, other one is in Sri Harikota. Then many space centers are in India. We can say that in different parts of India. As we studied, there are different centers of space mission in India. Then Indian scientists selected Sri Harikota as well as Thiruvananthapuram as rocket launching centers, or we can say satellite launching centers. Why did they select Thiruvananthapuram as well as Sri Harikota for launching artificial satellites? Its answer, this Sri Harikota as well as Thiruvananthapuram, that means we can say that Tumba launching station. These two places are at the equator. As a result of it, the speed or the velocity for launching satellite will be very high. As a result of it, the movement of the satellite or the speed at which the rocket move from the earth or from the surface of the earth will be very high. Because of that, this equatorial region like Thiruvananthapuram as well as Sri Harikota, scientists selected as rocket or satellite, artificial satellite launching centers. Now one more thing, for what purpose they are sending artificial satellites to the outer space? Now one more thing I will say, outer space, that is how much kilometers from above from the earth? We can say that approximately 100 kilometers above the sea level. Sea level means the surface of the earth. Approximate information is there or approximate measure is there. Here and there some changes also may occur. Now, why to send these satellites on the Earth's orbit or Mars orbit, or we can say Moon's orbit? It has a special function already we people studied. At present, more than 1,000 satellites already orbited on the orbit of the Earth, we can say. Now, because of the satellites, we can say that we are getting all information about the world. For example, if there is cricket match in different parts of the world, easily we can be able to understand, or all people can understand. If it is happening in India, other countries also, other country people can be able to watch well, listen well. TV is functioning because of, in TV, which all informations are coming, that is because of the functioning of satellite. Second thing we can say that in case if there is any war between two countries, the enemies having which all weapons with them. For detecting that also satellites are helping. Other thing we can say that our mobiles, that is again working because of the help of satellites. We can say that when one person starts speaking with the help of a mobile, the information first reaching or receiving by the satellite. Afterwards, which all information collected by the satellite, that will send to the listener. That we can say that the information what we are talking, that is receiving by the satellite. Afterwards it is sending to the person who is hearing. So from the satellite the information is sending. So we can say that the satellite transmitting the information to the listener, hearing person. So we can say that one person is the sender, other person is the hearing person, listener we can say. So one person speaking, that information reaching to the satellite, artificial satellite, again it sends the information to the person who is listening. Here we can say that with the help of electric signals, the information reaching to the satellite, even it is coming from satellite to the listener. Now again we can say that at first the satellite, the artificial satellite sent to the outer space by Russia. The first satellite, first artificial satellite which is sent by Soviet Union or Russia, that is known as Sputnik. Sputnik. This is happened in the year 1957. After that, other countries started to send the satellites to the orbit of the Earth. Now, here we can say that there are rocket, or we can say spacecraft. Their duty to carry the satellites with them and placing the satellites on the orbit of the Earth. So here we can say that for carrying the artificial satellites, some vehicles are helping. Those vehicles we can say is either rocket or spacecraft we can say, or space shuttle also we can say. So spacecraft, we can say rocket, again we can say space shuttle. These all are the different vehicles which help to move towards the space. Now we can say that in the spacecraft, rocket, etc., they carry the artificial satellite with them. After that, this artificial satellite will settle or will fix on the orbit of the Earth. Now how they look, that we'll see. Here we can say that artificial satellite which is going or which is fixing by the spacecraft or rocket. This artificial satellite which is going in or which is remaining on the orbit of the Earth or Moon or Mars. Such a artificial satellite has two wings. This is fixing here with the help of this what we can say stand. It will fix on the orbit of the Earth. Then here we can say, here means you can find that two wings of the satellite which is fixing on the orbit of the Earth, Mars, or we can say Moon. Now, these two, this and this, these two wings are made with the help of photovoltaic cells. Photovoltaic cells. Now, photovoltaic cells, its function is there. It can, these cells which are fixing on these two wings, they can convert solar energy to electrical energy. They can convert solar energy to electrical energy. As a result of it, once these satellites orbit on the Earth, from that time onwards, they start using electrical energy which is getting or which is producing by the voltaic cell. So further and further, no need of charging from the Earth. It is automatically charging with the help of solar energy. So continuously these satellites can be, such as satellites can be able to function without stopping on the orbit of the Earth. Now these satellites having the speciality to keep on moving continuously around the Earth in the specific orbits. So for its movement, energy requirement is there. That energy is getting with the help of photovoltaic cells which are fitted on both the wings of the satellite. These satellites carrying work and fitting or fixing on the orbit of the Earth, that is happening with the help of these space vehicles, like we can say spacecraft, rocket, as well as a space shuttle. Now one more speciality is there. Some of the space vehicles having the capacity to come back to the Earth. Once it will go, it will reach the people or it will reach the satellite there. Again it is having the capacity to come down to the Earth. Some of them are not having, but some of them are having the capacity to travel again and again. That is from Earth to there and from there to here. There are different types of satellites. One we can say is weather satellite. Weather satellite, its function what is there? Just for understanding the weather. We can say that whether it is cold weather, then very humid weather is there or what. Even we can say that the rain is going to fall or very high temperature will be there. Full information can be able to give us with the help of weather satellite. We'll see what is the function here given. For forecasting. Forecasting means for informing us about the weather. Whether storm is going to occur, cyclone is going to occur, or we can say that flood is going to occur, then earthquake is going to occur. About each and every information is giving with the help of weather satellite. Now weather satellite, its example INSAT. Inset we can say, GSAT, that is GSAT we can say. Now these two satellites are giving information about the weather to us. So these satellites we can say as weather satellites. Now these weather satellites, launcher means a vehicle which is carrying these satellites, known as Gslv Launcher. Gslv Launcher. This is the space vehicle which is carrying these satellites to the orbit of the Earth and fixing them on the orbit of the Earth. Now other satellite, that is known as a communication satellite. Communication satellite's function, giving information of all over the world. Its function is giving communication, information about which all things are happening, what is happening in different parts of the world. So here communication satellite helping us to getting information about each and everything which is happening in the world. Now for that again we can say that the satellites INSAT as well as GSAT, these two satellites again helping for giving information of each and everything which is happening all over the world. Now again we can say that the launcher also same, that is Gslv Launcher. Now we are studying about other type of satellite, that is known as broadcast satellite. Broadcast satellite's function is to giving or to telecasting, for telecasting TV programs. In TV different programs are coming continuously. For telecasting that, this broadcast satellite is helping. Again this broadcasting work is happening because of the help of again these satellites only, that is INSAT and GSAT satellites. Now to them launching with the help of Gslv Launcher. Gslv Launcher placing these satellites on the orbit of the Earth. Placing alone not, to them carrying from the Earth to the outer space, we can say that, which is above the surface of the Earth. Now so here we can see that this is a launcher. Launcher means it is a vehicle which can carry these artificial satellite to the orbit of the Earth, and it can be able to place them there or fix them on the orbit of the Earth. As a result of it, we can say that these two types of satellites can give information about weather, then it can give all information about the world. Again we can say that it can be able to telecast TV programs. Now we are studying about navigation satellite. Navigation satellite is having the function of fixing or finding any part of the world, we can say. Detecting work, we can say. Locating different areas of the world. Actual place where it is there. So here what is here given? Fix the location of any part of the world. Now seeing the latitude, position of the latitude, position of the longitude, seeing everything. Perfect, we can say. Precise idea, precise knowledge, accurate information about the location of different areas, different parts of the world is happening because of the help of navigational satellite. Navigational satellite, for that example given here, that is IRNSS. IRNSS, this is the name of the satellite which is helping for locating or finding the actual location of any part of the world. Any doubt, any clearance required. So the actual position want to find out. For that this navigational satellite is helping. Now its, that is IRNSS satellite's launcher is Gslv Launcher. Now the other one, military satellite. Military satellite is helping for the security purpose. It is helping means any enemies are going to attack us or attack our country. For detecting that, this military satellite is helping. Now military satellites example not given in our book, even though I am giving you few examples, that is GSAT-7 and GSAT-7A. GSAT-7 and GSAT-7A. GSAT-7 and GSAT-7A. These two are the satellites which are using for security purpose. Now these satellites launchers different. That is GSAT-7 satellite, its launcher is Ariane 5, and GSAT-7A, its launcher is Gslv Launcher. Now these two launchers are carrying, example Ariane 5 carrying GSAT-7 and GSLV carrying GS87A satellite. With the help of these two satellites, we can understand there are different types of satellites, but here I given only two names. These satellites are helping us for protecting our country from enemies. Where how much weapons are there with the enemies, which all weapons they are using for attacking us. All information can be able to give by this military satellite. Full idea about the enemies can be able to detect with the help of military satellite. Here now two military satellites name I written. One is GS87, other one GS87A. Now GS87, its launcher is Ariane 5. GS87A, its launcher is Gslv. Now we will study about Earth observation satellite. Now what is happening on the Earth? For detecting that, here Earth observation satellite is helping. Now with the help of this Earth observation satellite, we can be able to understand in detail about forests, then deserts, oceans, even we can say minerals, how much petrol is there, how much petroleum product is there, how much natural gas is there under the earth. Even we can say that how much metals are available, gold how much is there, gold mines where, then other type of metals where it is available. Full information can be able to get it with the help of Earth observation satellite. Even we can say that any calamities are going to occur, that means a flood, or we can say that any storm or any earthquake, any type of calamities is going to affect the earth or not, affect India or not, for or other country or not. For understanding that, this Earth observation satellite is helping. Now here one example we are having, that is IRS. This is the name of the satellite which is helping for Earth observation. Now this satellite launcher is PSLV launcher. So PSLV launcher helping for lifting or carrying IRS satellite and helping for reaching it to the Earth's orbit and helping for fixing it on the Earth's orbit. Now we will study orbits of artificial satellites. Now here all artificial satellites do not revolve around the similar type of orbits. For example, we can say that suppose this is the Earth. This is the Earth. So we can say that this is its equator. Now we can say that around the equator, we can say that parallel to the equator, there will be orbits. We can say that even longitudinal direction, like that way also orbits are possible. Even we can say that some angles, again orbits are possible. So we can say that in some angles, then we can say as second thing, parallel to the equator. Then we can say that height, depending upon the height. Depending upon the height of the orbit. Then one more thing we can say that whether it is in elliptical orbits shape same, that is nature of the orbit, whether it is elliptical or circular. So depending upon the height of the orbit, we can say that depending upon whether it is parallel to the equator or we can say that it any depending upon any angles. Like that way we can say, like that way any angles we can say, such any angle, 90-degree angle, 80-degree angle, 50-degree angle, like that way, different way the orbit formation is possible. So different types of or different satellites are fixing on different orbits. Now that fixing work is leading or guiding from or with the help of remote control from India or from other country, guideline will give to the launcher. As a result of it, which orbit it has to fix, that decision will occur. Then the launcher will go and fix the satellite. Now here we can say that suppose if there is like that condition, we can say that this is a parallel to the Earth's equator, its orbit. We can say that now with any other angle we can see, like that can be, or we can say even like that way, any angle. So like that way, with different angle, orbit formation is occurring. As a result of it, the position of the satellites, artificial satellites, will be in different orbits, as well as it will be at different heights. So here, once they fix, now suppose this is the Earth. Now suppose such a way one orbit I made. This is the central position of the Earth. This is its radius of the Earth. This is the radius of the orbit. Now I am fixing one satellite here. Just imagine we are fixing one satellite here. Once it will fix the orbit with the help of a launcher on the orbit of the Earth, then giving a specific velocity to it. One specific velocity is given to it. As a result of it, it starts to revolve around the Earth with a specific velocity. So the velocity which is receiving or which is getting to the satellite, that is known as critical velocity. Its name is critical velocity. Its symbol is critical velocity, that is V then small c. Critical velocity. With the help of that critical velocity, the satellite start to revolve around the Earth. Now, one more thing is there, the functions of the satellite that is deciding the height of the deciding by the height of the orbit from the Earth. One thing. Second thing we can say nature of the orbit. The third thing we can say that at which angle it is fixed. At which angle the orbit is present. So we can say that here on which orbit satellite is fixed and in which direction that orbit is there. So these all things decides the function of the satellite. Now how much height? Now we can say that this is one orbit I made. Now very far from the surface of the Earth, other orbit I can make. Again very far I can make it. So like that way, from the Earth how much far it is or how much close it is there. So that decides which function a particular satellite has to do. Now we have to derive one equation. How to derive critical velocity of an artificial satellite. Now critical velocity, its symbol is V c. This is the symbol of critical velocity. Now, this is the Earth. This is its central part. This is its radius, capital R. This is its one orbit. Now, just imagine here the artificial satellite already fixed. Now, from here till here, we can say that the height of the satellite from the surface of the Earth. Now, here all together, from here till here, same way I am showing you here, from the center towards the orbit, the distance that we can write as, or we can say the radius of the orbit, that we can be able to represent by putting the letter small r. So here now, this is the radius of the Earth. This small r is the radius of the orbit. The h shown, that is the height of the satellite from the surface of the Earth. Now, here from the center of the Earth towards this satellite, there will be a pull, an attraction. That is known as, that attractive pull we can say as centripetal force. Centripetal force. So here we can say that the centripetal force, center seeking force we can say, that means towards the center of the Earth, this Earth pulls this satellite every time. Now that centripetal force, for finding that we are having one formula with us, that is mv square upon small r. Here this v means the critical velocity. So we can write here now small c. So mv square means mvc square upon r. Now here r means what? This is r. R means we can say this way also, that is r plus h. Then here we can say that now centripetal force is equal to gravitational force between Earth as well as satellite. So we will write now centripetal force, that is mvc square upon r means I am writing as this r plus h, capital R plus h. Now that is equal to capital G into capital M into small m upon capital R plus small h whole square. This formula we had already studied, gravitational force of the Earth as well as other object. Here now we have satellite. If there is any other object will be there from Earth's surface. So its gravitational force, that means the gravitational force exerting by the Earth on other object. Here now satellite is there, or instead of satellite any other object. Then it's a formula we had already studied, that is capital G into capital M into small m. Capital M means the mass of the Earth. This is the gravitational force exerted by the Earth. We can say gravitational constant. Then M is the mass of the satellite upon the distance, that is R means the radius of the Earth, H means the height of the object, height of the satellite from the surface of the Earth. It's a square. Now we will do the cross multiplication of both of them. As a result of it we will get mvc square into capital R plus capital H whole square. Then it is equal to here R plus H into capital G, capital M, small m. After that, now mvc square we will keep this side, that is equal to this thing we will take it down. Why? Because here into form is there, then it will be here in the form of division. So same we will write capital R plus capital H into capital G, capital M, small m, upon we will take this down, that is capital R plus capital H whole square. Now this square and this will cancel out. Now MVC square, that is equal to G capital M, here small m, here also small m, upon capital R plus small h. Now we will keep only this V square here, that is VC square, that is equal to this m we are taking to this side. Here now multiplication form, when it will go here, it will be in the division form. G m small m upon capital R plus H into m. Now this m and this m will cancel and go. Therefore we will get VC square, that is equal to capital G capital M upon capital R plus small h. Now we have to find out VC. So here we will find out now. Therefore VC, here VC square we have got. So VC is equal to square root of G M upon capital R plus small h. This is very simple derivation is there. So in this way we can be able to find out critical velocity of the satellite.